Hello, this is Mrs. Ward, and I'm going to go over the 2.1 practice worksheet. So the first one says use the definition of a derivative to find the derivative of each function with respect to x. So that's when you're doing the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And remember, notation is important. So if you don't like the delta x, you can use h as long as you're consistent and you replace delta x with h everywhere. I'm going to stick to the delta x. So I'm going to take the limit as delta x approaches 0 of f of x plus delta x. So that's going to be x plus delta x plus 5 minus f of x, which is x plus 5, all over delta x. Still taking the limit as delta x approaches 0, and this will be x plus delta x plus 5, distributing the negative sign all over delta x. Still taking the limit as delta x approaches 0. Here the x and the x will equal 0, the 5 and the 5 is equal to 0, and the delta x is simplified. So I had delta x over delta x, which simplifies to 1. So when I go to take the limit as delta x approaches 0, there's nowhere for me to place it because there's no delta x left. So this is just going to be 1. So, and that should make sense to you because this is a line. The slope of this line is 1. So the slope of any tangent line at any given point is going to be consistent, and it's always going to be 1. So that makes sense. All right, now I'm going to do number 2. I'm going to switch colors so I can see what I'm doing. I'm going to take the limit as delta x approaches 0. In every place I see an x, I'm writing x plus delta x minus f of x, and this is all over delta x. So I'm taking the limit as delta x approaches 0. This, you should know that x plus delta x squared is going to be x squared plus 2x delta x plus delta x squared. So I'm going to know that and distribute the 3 at the same time. Oh, here's my plus. Ooh, wrapping around. I don't like wrapping around, but I didn't leave myself enough room. Distributing the negative sign, and this is all over delta x. I'm going to cross out what can cross out. So the 1 will simplify with the 1. No particular order that I'm doing those in. Everything that I have left should have a delta x. So I'm going to factor out the delta x as I write the next line. So factoring out the delta x, I'll be left with 6x. This is delta x squared, so I'll be left with 1 delta x. And then I am going to be left with plus 5 all over delta x. Here, the delta x's will simplify, which is great, because now I can, as I'm taking the limit, as delta x approaches 0, I can do direct substitution because that 0 in the denominator is now gone, so it's no longer a problem. So I'm going to have 6x plus 3. In place of that delta x, I'm going to write 0 plus 5. And when I'm done, I end up with 6x plus 5. Remember, this is the derivative, so I'm going to go up here. I believe it's just y is equal to. So the derivative is 6x plus 5. Oh, and I should have written the derivative is equal to 1. Yeah. Okay, moving on. Next one. So this is a practice worksheet, so I'm not grading it. So if you got that one, you understand what you're doing. 3 and 4 are exactly the same, so if you don't need to do them, don't do them. I don't know what else to tell you. Limit as delta x approaches 0, but I kind of think they're fun. But my definition of fun and your definition of fun might be slightly different. And then I'm going to do minus f of x, which is, and this is all over delta x. Okay, remember that's x squared plus 2x delta x plus delta x squared. I'm going to distribute the 5 at the same time. Distributing the negative 5. I'm just going to keep on going and I'll worry about the next one later. Just distributing the negative sign. Then I'm going to simplify what can simplify. So the 5x squared will equal 0, the 5x's will equal 0, and the 2 and the positive 2 will equal 0. Remember, everything that doesn't have a delta x should simplify. So basically, this here was this minus f of x. All that should simplify because none of that will have a delta x. Everything is left will have a delta x. I'm going to factor that out when I go to write the next steps. I'm going to have 10x plus 5. This is delta x squared, so 1 delta x will remain all over delta x. Now my delta x's will simplify. I'm still taking the limit as delta x approaches 0. Now I can do direct substitution because I don't have a denominator. I can put 0 in for that delta x. So I'm going to have 10x plus 5 times 0 minus 5. So my derivative is going to equal 10x minus 5. Okay, doing the next one. Okay, now I have more room, so I'm still going to do the limit as delta x approaches 0 of 4 minus f of x. Remember, put it in parentheses so you do not forget to distribute that negative sign. And if you make a mistake when you square and distribute, then take the time to write it as 2 steps. So this will be 4x squared. I will tell you the most common mistakes that people make is that here they forget this x. Remember, it's x times delta x. If you use an h, you're less likely to make that mistake. And then the next common mistake is coming up right now. So here I'm going to simplify what I can simplify. So the 4x squareds, the 5s, and the x all simplify. Everything else left has a delta x. So I'm going to factor out the delta x. Now, this is 8x, that's clear, and then here's plus 4 delta x, because that's delta x squared, you're only taking 1 away. I have this delta x, has a plus sign in front of it, so I'm going to have plus 1, because if I took delta x times 1, that would give me that delta x. Do not forget to put that placeholder in there. All right, now the delta x's will simplify, which makes me able to put in 0 for delta x. So I'm going to take the limit as delta x approaches 0 of 8x plus 4 times 0 plus 1. And so my derivative is going to be 8x plus 1. Okay, doing the next one, I have a square root that should not bother me. I'm going to do it the same way I've done it before. I'm going to take the limit as delta x approaches 0 of the square root. In place of this x, I'm going to write 5 times x plus delta x minus 4, and then I'm going to subtract the function, which is this 5x minus 4, and I'm putting this whole thing over delta x. Well, right now you might be confused as to what to do, but you know if you substitute in 0, you're going to have 0 in the denominator, but fun fact, you also have 0 in your numerator. So since I have that 0 over 0, that tells me that I can do something. I can somehow simplify it. So I'm going to remember what I learned in last section, I hope, and I'm going to multiply by the conjugate of this. So I'm going to multiply by 5 times x plus delta x minus 4. Everything that's underneath the radical sign stays exactly the same. Since this is a minus sign, I'm going to change this to a plus sign. And 5x minus 4. If I multiply my numerator by that, I'm definitely going to have to multiply my denominator by that, because you can't just go rogue and multiply your numerator by something without making it equal. So when I do all this, this, remember, is the difference of two perfect squares. So basically the radical signs go away. Everything underneath stays the same, and it's going to be minus. So I'm going to have 5 I'm going to distribute my x too. 5x plus 5 delta x minus 4. That's this guy. Minus, and then in parentheses, 5x minus 4. All over delta x times all that. So here when I distribute this negative sign, this will be, I'm going to kind of cheat, a little bit of cheating going on here. This will be minus 5x, and then when I distribute that negative sign, this will be plus 4. Okay, so that's legitimate what I just did. And now I am going to simplify what I can simplify. So the 5x's will equal 0, the 4's will equal 0, and I'm still taking the limit as delta x approaches 0. And I have 5 delta x over delta x times all this. Now the delta x's will simplify, which is great. That means I can put 0 in for delta x because I took care of that problem in my denominator. So I'm going to have 5 over, and it's going to be the square root of 5 times x plus 0 minus 4 plus the square root of 5x minus 4. So if this is 0, then this is 5x minus 4, and this is 5x minus 4. So I have two of them. So I'm going to write 5 over 2 times the quantity of 5x minus 4, the square root. And that will be my derivative. Okay, moving on to do the next one. Same thing, square root of negative 3x plus 1. So I'm going to take the limit as delta x approaches 0. I am going to put x plus delta x in for that x. Now again, when I try and put in 0, I realize that I can't simplify because I get 0 over 0, so I am going to multiply by the conjugate. So let's multiply by the conjugate. Everything underneath the radical sign stays exactly the same as it is. If you want to go ahead and distribute this, why don't we just do that now? Negative 3x minus 3 delta x plus 1 minus the square root of negative 3x plus 1, and closing that parentheses, and we're going to multiply the denominator by the same thing. I don't know what's easier for you, whether to keep it with the 3 outside or distribute it, your choice. So here I'm going to take the limit as delta x approaches 0. So now when I multiply this times this, the radicals go away, so I have negative 3x minus 3 delta x plus 1. Distributing that negative sign, plus 3x minus 1, all over delta x times, and then nothing changes. Now the negative 3x and 3x will equal 0, the 1 and negative 1 will equal 0, and sure, why not? So taking the limit as delta x approaches 0. At this point, the delta x's will simplify. Whoopsie, just the delta x. And I'll be left with that negative 3 over all this. And at this point, it's okay for me to put 0 in for delta x, so this will be negative 3 over the square root of negative 3x minus 3 times 0, which means that term will go away. Oh, Mrs. Ward. Mrs. Ward made a boo-boo. All right, back up here. People, why didn't you yell at me? You were probably yelling at me the whole time, but you know, I could go correct this, but I'm not going to because this should have been a plus sign. Yeah? Yeah. So that's a plus sign. Hopefully you caught that. This is a plus sign. This is a plus sign. Okay, life is now good. And that's a plus sign, so now I have two of them, so I have negative 3 over 2 times the square root of negative 3x plus 1. I knew it couldn't be a minus sign because this would have been the same thing minus the same thing, which would have left me with 0 in the denominator, and I knew that wasn't the answer because that means I wouldn't have a derivative, and I know I have a derivative at that point. All right, sorry about that. I hope you weren't screaming at me too loudly when you were doing that at home. And let's do, next one is I have a rational function, which is okay. So I'm going to do the limit as delta x approaches 0. We did all these when we were doing limits, so you should be familiar with these. So I'm going to take 1 over x plus delta x plus 2 minus 1 over x plus 2. And this whole thing is over delta x. Now, when I go to do this, I need to have a common denominator. So I am going to choose to multiply this fraction by x plus 2 over x plus 2. This fraction will be multiplied by x plus delta x plus 2 all over x plus delta x plus 2. So I'm multiplying each part of the fraction by 1, multiplying to make sure I have a common denominator. So when I do that, I'm going to have the limits as delta x approaches 0. When I distribute the 1, that'll be x plus 2. I'm going to go ahead and distribute this. I'm going to think of this as a negative 1 and distribute that negative 1. So this will be minus x minus delta x minus 2. My denominator for this up here is going to be x plus 2 times x plus delta x plus 2. And I'm dividing it by delta x over 1, so I'm going to think of that as multiplying by 1 over delta x. Remember, when you divide, you multiply by the reciprocal. So in the numerator, the x's will simplify, the 2's will simplify, and I'm left with negative delta x over this x plus 2, x plus delta x plus 2, and this is times 1 over delta x. And I'm still taking the limit as delta x approaches 0. Here, the delta x's will simplify, and I'm left with a negative 1 in my numerator. Got to have something up there. So limit as delta x approaches 0. Now, at this point here, when I go to write this, I'm going to put 0 in for this delta x. I'm going to have x plus 2. And then that will be x plus 2 as well. So my final answer is going to be negative 1 over x plus 2, and I'm going to write that quantity squared. Oh, that's a bad 2. Very bad 2. Okay, moving on. So same again, I'm taking the limit as delta x approaches 0 of 1 over x plus delta x plus 4 minus 1 over x plus 4. This whole thing is over delta x. In order to do this, I need to have a common denominator, so I'm going to multiply this one by x plus 4. And I'm going to multiply this by x plus delta x plus 4. And so when I do that, distributing this 1, I'm going to have x plus 4. Distributing this negative 1, I'm going to have minus x minus delta x minus 4. This is all over x plus 4, x plus delta x plus 4. And I'm multiplying it by the reciprocal of the x over delta x over 1, so 1 over delta x. And I'm going to take the limit as delta x approaches 0. Here, the x's will equal 0, the 4's will simplify, and I'm left with a negative delta x over this times 1 over delta x. Now I can plainly see that my delta x's will simplify, and I'm going to go ahead and substitute 0 in for this delta x because I can. And I'm going to end up with x plus 4. And I have 2 of those, right? And I'm multiplying, so this will be squared. and that'll be my derivative. Okay, the next one is, it tells me, it says find the slope of the tangent line of the graph at the given point using the limit process. So when I did the answer key, I did the limit process where I put in C and subtracted C. And you can do that, but then I thought, why did I do that? Why shouldn't I just do the alternate form? So on the video, I'm going to do the alternate form. Either one is correct. In fact, you could do exactly what we just did and do that x plus delta x minus f of x all over delta x and then substitute in 2 at the end. You can do that as well. So I'm going to do this one using the alternate form of the derivative. And if you don't remember what that is, that's when you take the limit as x approaches c of f of x minus f of c all over x minus c. So you can't do direct substitution at first because you'd have the 0, but you can simplify that. So just to remind you, this 2 would be my c, this 11 would, negative 11 would be my f of c. So when I'm using this formula, I'm going to take the limit as x approaches c, which is 2, and then I'm going to write f of x exactly the way it is, no delta x needed, no plus anything, just write that. And then I'm going to subtract f of x, which is at negative 11. And I'm going to put this all over x minus 2. Then I'm going to simplify, so I'm going to have, still taking the limit as x approaches 2. And this is only going to give me the derivative at 2. It's not going to give me the formula for the derivative. It's just very specifically going to give me the derivative at 2, or the slope of the tangent line at 2, however you want to think about it. So I'm going to take negative 3x squared minus 2x, and then the 5. So this will be plus 16 all over x minus 2. So now I'm going to factor the numerator, and when I factor the numerator, here's a huge hint. If you did everything right, one of your factors should be x minus 2, because this x minus 2 has to simplify with the x minus 2. Product is going to be negative 48. My sum is going to be negative 2. Now that lead coefficient of negative always throws me off. I could try and factor that out, but I'm not going to because that's just going to mess me up later on. So I'm just going to have to struggle through it. My factors of negative 48 that add up to negative 2 are going to be negative 8 and positive 6. Now back in Mrs. Pesic world, you wrote this as negative 3x squared minus 8x plus 6x plus 16, and you did what you had to do. I'm not going to do it that way. I do what's called the slide and divide. So I write these down as x minus 8 and x plus 6. Now, I know that doesn't work because I don't have that lead coefficient of a negative 3. So that's where the slide and divide part comes in. So I am going to divide both of these by whatever my lead coefficient is. In this case, it's negative 3. If it does not simplify, like negative 8 and negative 3, that does not simplify. There's no way it simplifies. I can't put in lowest term. That's just what it is. So I'm going to slide this 3 over here. So this will be negative 3x minus 8. And I'm going to leave it like that. I know I have 2 negative signs in there, and that's okay. Here, when I take 6 and I divide it by negative 3, that's negative 2. So I'm going to make this x minus 2. And that works. If I check it, this would be negative 8 plus 6. That gives me the negative 2. So it does work. So that's a quicker way of doing product sum if you want to. If you don't want to, then don't listen to me. So here I have that x minus 2. I knew that already. Then negative 3x minus 8. Whoopsie, I was going to write a plus sign. Minus 8. When you're doing these, this factor should simplify. So then when I divide, the x minus 2's will simplify. So now I'm taking the limits as x approaches 2. So all I have to do is, because now that I don't have a problem with the denominator being 0, is do direct substitution. So I'm going to have negative 8 minus negative 6 minus 8, and I'm going to get negative 14. So my slope, what does it ask me for? It's been so long, I forgot. It says find the slope of the tangent line. So the slope of the tangent line when x is equal to 2 is negative 14. That's just when x is equal to x is equal to 2. Okay, let's do another one. I'm going to do the same process that I just did. I am going to take the limit as x approaches -1, because that is my c. Negative x squared minus 3x plus 3 minus f of c, which is 5. And this is all over x minus a -1. I know you would never write it like that, but I'm just showing you what I did. So this will be negative x squared minus 3x minus 2 all over x plus 1. Okay, I can't deal with that. I said I was going to deal with it. I lied. So this factors with that negative sign as x plus 2, x plus 1. That's a baby one, the factor. So I'm going to take the limit as x approaches 1 of a negative sign x plus 2 times x plus 1 all over x plus 1. These x plus 1s will simplify. So now I'm going to take the limits. Whoopsie, was it -1? It was. I'm going to take the limit as x approaches -1. And then so I'm going to have a negative times x will be -1 plus 2, because I can do direct substitution. So this is -1 times a negative, so this will be 1. So I am going to say the slope of the tangent line. Oh, no, it's -1. The slope when x is equal to -1 is -1. So the slope happens to equal to x. That's just a coincidence. Okay, next one. So number 11, same thing. So I'm going to do limit as x approaches 1/4 of 1 over x plus, no, x approaches 0, Mrs. Ward. X approaches 0 of x plus 4 minus 1/4 all over x minus 0. I'll write minus 0, but I'll fix it in a second. So the limit as x approaches 0. This is still the same process. I still have to have a common denominator, so I'm going to multiply this by 4 over 4, this by x plus 4 over x plus 4. So I'm going to have 4 distributing this negative sign minus x minus 4 all over 4 times x plus 4. And this is all over x minus 0, which is just x. So now I'm going to take the limit. Here, these will simplify, the 4 and the -4. So I'm going to have negative x over 4 times x plus 4 times the reciprocal of this, which would be 1 over x. Now the 1 over x's will simplify, which means I can do direct substitution at this point. And when I do that, I'm going to have -1 over 4 times 0 plus 4. So I'm going to get a -1/16. So the slope of the tangent line when x is equal to 0 is -1/16. Okay, doing the next one. I'm going to take the limits. Now my c is 5 as x approaches 5 of 1 over 2x plus 1 minus 1/11 all over x minus 5. So I'm going to take the limits as x approaches 5. Remember, I need a common denominator. So I'm going to multiply this one by 11 over 11, this one by 2x plus 1 over 2x plus 1. So when I do that, I'm going to have 11 distributing that negative sign minus 2x minus 1 all over 11 times 2x plus 1 all over x minus 5. Big compound fraction. That doesn't bother me. So here, when I combine my like terms, so I'm going to have 11 minus 1. So that'll be 10 minus 2x over 11 times 2x plus 1 times, and then I'm going to multiply by the reciprocal of this, so I'm going to multiply by 1 over x minus 5. Still taking the limit as x approaches 5. Still can't do direct substitution because it'll make this denominator equal to 0. But I see here that I can factor out a negative 2 and make that negative 2 times x minus 5. And then I'm taking the limit as x approaches 5. At this point here, the x minus 5s will simplify, which means now I can do direct substitution. So I'm going to put 5 in. So I'm going to have negative 2 over 11 times 2 times 5 plus 1. So that's 10, 11, 121, negative 2 over 121. So that is so the slope of the tangent line when x is equal to 5 is negative 2 over 121. Okay, and then 13 and 14, it says find the equation of the tangent line of the graph at the given point. So I'm going to do the same thing I've been doing, but then I'm going to take it one step further. So I'm going to do the limit as x approaches negative 1 of f of x minus f of c, which is 4, all over x minus a negative 1. So when I do that, up here that'll be 5x squared plus 5x. The 4's will equal 0, so those are gone, all over and then plus 1. I can see in the numerator I can factor out a 5x, so make a 5x times x plus 1. Remember, this denominator should simplify. So I'm going to take the limit as x approaches negative 1, so that's going to be 5 times negative 1, and that's going to be negative 5. So remember, the slope of my tangent line is going to be negative 5, and it's asking me to actually find the equation of the tangent line. So it doesn't just want the slope, it wants the whole line. So remember, it's going through this point, negative 1, 4. So now I'm going to write a line that goes through the point negative 1, 4 that has a slope of negative 5. Remember, I'm a point slope girl, so I'm going to do y minus 4 is equal to my m times x minus negative 1, so plus 1. So this is going to be negative 5x minus 5 plus 4, so minus 1, I believe. So negative 5x minus 1. That is the equation of my tangent line at the point negative 1, 4. So this is so much less work than what I did on the answer sheet. So much more less work. So I'm going to keep on using this alternate form. So now I'm going to do the next one. So I'm going to take the limit as x approaches 3 of 2x squared plus x plus 3 minus 24 all over x minus 3. So I'm going to take the limit as x approaches 3 of 2x squared plus x minus 21 over x minus 3. Now here's a hint. If you don't like product sum, well, you got to get over it. You know, you just do. But x minus 3, that has to be one of my factors, x minus 3. So the only way I can get 21 times negative 3 is 7. So that has to be 7, which this has to be a 2x. And then just see if it works. And this would be 7x plus 7x minus 6x, and it works. Or you can factor it. You can do, you know, whatever you do. So I am going to take the limit as x approaches 3. So this will be 2 times 3 plus 7. So this will be 13. So my slope of my tangent line is 13. I am going through the point 324. So I'm going to do, what am I going to do? I'm going to do y minus 24 is equal to my slope times x minus 3. So y minus 24 is equal to 13x minus 39. So y is equal to 13x minus 15.